I'm an idiot. Hey guys, I just suddenly looked at my timings for this thing and I put PM instead of AM. Oops. Yeah, I can't even change it now because I'm live already. Lol, that's really funny. How's it going to be a late night lesson tonight? Thanks, Julian. I totally missed that bit. How's it going to be a late night? Oops. Oops. Oh well. Yeah, my bad. I wonder if that's going to freak anyone out. It might do. Oliver, Manisha, Julian, Ange, Aisha. That's great. Oh, what? Oh, I did do it. What are you talking about? What? Oh, hey. What's the date? The date is the 1st of June today, and it's a Monday. I do the register. 1st of June. Lesson 3, 4? 4. 1st of June. Oh, apparently I've got a Monday missing. Oh, whatever. Control C. There we go. I don't care. I don't care. There we go. Right. Do we have Adam? I haven't seen Adam yet. I've got Angel. Seen Angel just now. There's Angel. Yeah. I've got Anch. Seen Anch. Yeah, seen Anch. I think there was. Were we on the? Were we in on the 25th of May? I don't think we were. Got Aisha. Alistair. Haven't seen Alistair yet. No, not seen Alistair yet. Isha. Problem is, I'm doing this. There we go. There's Isha. Yeah. Emmeline, Minwi, Hamani, Misha. Yeah, I'll add those in. I've not got Alistair yet. I've not got Adam yet. Hamani. Meryl. Haven't seen Meryl yet. Where's Meryl? Adam. There you go. Looking fly. Thanks, Adam. Oh, you're funny. Got Oliver, got Julian. Nick, of course, isn't here. Has anyone seen Murdo? Haven't seen Murdo yet. He's not here either. Got Misha, got Minwi, got Manisha. No Meryl yet. No Meryl. Missing Alistair, and Adam is now in the house. Okay, I'll leave that as that. They're not here. Oh, there's Alistair. Just showed up in time. Whew. There we go. So I'm missing Meryl, Murdo. Those are my only two people I'm missing. Meryl and Murdo. Murdo is coming. Yeah. Yeah. So he's not here now. Got no Meryl either. Okay, guys, we've got homework to go through. Let's crack on. I'm cracking on with this. If they're not here, they're not here. That is, they need to try and get here earlier. They're 5 minutes late now. I need to crack on my lesson. Lost 5 minutes per lesson. Let's crack on. Right. Hide that. Go for that one. That one. Now I set you guys a homework to do. Can everyone please on the chat? Did everyone manage to get it done? I'm kind of hoping that you did. Insert printout. There's Murdo. I set you guys some redox half equations for homework. Wi-Fi problems, I'm here. Okay, no problem. So I set you your Moe style. I like it. Yeah, great job. Thank you, Manisha. Thanks, Oliver. Thanks, Hamani. Thanks, Emmeline, Isha, Misha, and Minwi. Yep, done. Thank you, guys. Cool. So let's kiss some half equations, shall we? Right. Okay. So I taught you the method. You just had to apply it. Yeah, and I gave you, there's a nice mixture here. Mixture between complex and simple. Nice and easy. Shouldn't have taken you that long to do either. So the first one was a super, super easy one. Na going to Na+, and you should have gone +1 electron. Tick it if you've got it, folks. Thank you. I'm going to do this in red. Prefer it to be in red since I'm marking. Yeah, sodium going to sodium 1+. The electron must be on this side. Yeah, tick it if you've got it. Most common thing is that students put them on the wrong side. Be careful. Yeah, on this side, we have no charge. On this side, it was +1. Bring it down. It goes on the more positive side because electrons are attracted to positives. It's because they're negative. They're going to be on the more positive side. Next, lead 2. So we got Pb +4. It's an unusual rarity. Going to Pb2+. +2 electrons on that side. I like it. Bring the more positive down. So it's nice just to add in little bits of detail here. I might add to the worksheet here. Yeah, because redox, reduction is the gain of electrons. Yeah, reduction is gain, and in the word gain is in. Yeah, gain, and oxidation, yeah, is out. Yeah, so this one here is ox. This one here is red. I like it. Yeah, next. So the first two are really Miss Hi, Mr. Duncan, sorry I couldn't find the link even though I kept refreshing it. Can you just put +E-? Ange, the answer is yes, they will allow just that in this case. Absolutely, Ange. That is correct. But I do like the number 1 to be there. It just because it's just good routine. Yeah, but absolutely, of course you can. Next, this now becomes GCSE level. Yeah, because you had to balance for atoms and then balance for charge. Yeah, 2 hydrogens, 2 hydrogens. Balance for electrons, +2 E- on that side. Tick it if you've got it, and it is going to be an ox. Oxidation is lost, which is out. Next, Br- going to Br2. Balance for atoms, balance for charge. The electrons will be attracted to the more positive side. On this side, it's 2-. On this side, it was 0. This is more positive than that. It's going to go onto that side. Yeah, I like it. Tick it if you've got it. And that one is also an ox. Ox is out. Yeah, and the electrons are coming out. Right, your first complex now makes an appearance. So this is now a true complex half equation. Yeah, and so now we're going to run Moe. Yeah, with metal, water, acid, electrons. Metal, 2 chromiums. Let's do the metal in green. Oh, it's a bit fat. Yeah, so 2 chromiums, 2 chromiums. I like it. Metal done. Yeah. Come on. Stupid tablet. Oh, stupid thing. Metal done. Water for oxygens. 7 here. I need 7 waters over here. Next, water's done. Oops. There we go. Water's done. Acid, H pluses. I have 14. Yeah. 2 what? Adam, why have you said 2 waters? It's got 7 oxygens in it, Adam, which means I'm going to need 7 H2Os because each water contains 1. Yeah, you're bad. 7 waters. Right, next, hydrogens. 14 hydrogens because it's 7 times 2. Each water has 2 in it. There are 7 waters. Right, here's the really tricky bit. Now add up for charge. So on this side, we had +14 and -2. Total charge +12. Next, on this side, I had +6 because I had 3 + 3s. Neutral from water, total +6. Add the electrons to the more positive side. +6 E-. And we're done. On the chat, please, give me a shout out. Who got it right? And is it oxidation or reduction? Yeah. Oxidation or reduction, and did you get it correct? Next. Right, SO4 2- going to S. Right. Moe me, baby. Yeah. Right. Metal, which is sulfur in this case, which is good. One sulfur, one sulfur. Oxidation, oxidation, reduction. Oxidation is loss. Yeah, really, Emmeline? Loss, ox is out. Ox is out. Where are the electrons? Yeah, the electrons are going in. Yeah, reduction is gain. That's a red. What a mess that was. Come on, guys. I need to add that to the worksheet because that was rubbish. Yeah, the electrons are, we know that reduction is the gain and it has the word in it. And the electrons are going in. It's a reactant. Come on. What's going on? Sheesh. Next. Right, Moemi. Let's kiss a half equation. MWAE. Mwah! Right, metal, sulfur. Yes. Water, I need 4 waters on this side. I need 8 H pluses because there's none on that side. Right, overall charge plus 6. Overall charge, that's easy, it's 0. Add 6, E minus. Another red. Reduction is the gain. I'm not having it today. Yeah. Making messes of this. Yeah, that's a red as well. Red is gain. Red is in. Yeah, next. SO4 2 minus going to H2S. Okay, Moemi. Yeah, metal, which is sulfur again, is okay. Remember, the M is anybody who isn't oxygen and hydrogen. Water for oxygen. Add H2O, and I need 4 of them again. Now, the H's are more. Add acid. I've got 8, 10. 10 H pluses. Now balance for charge. That side's easy. Plus 8 overall, because I've got plus 10 here, and minus 2 here. Yeah, plus 8. Add 8 electrons, and it's a red again. Yeah, Moe done. It's another red. Red is gain. Gain has in it. You get the gist. Yeah, look at all these SO2. S is kind of taken. That's rubbish. SO4 2 minus going to SO2. Yeah, so we're gonna have Moemi again. S is the metal. Add 2 waters because there were 2 oxygens already. Right, hydrogens, I need 4 H pluses on that because 4 hydrogens here. Balance for charge, 0 on that side, plus 2 on this one, add 2 electrons, and I'm done. Another red, another reduction. Blimey, loads of reductions today. Next. Right, N2 going to NO3 minus. Moemi. Metal is nitrogen in this case. Yeah, so I need 2 of them. Water for oxygen. I need 6. 6 H2Os. Next, hydrogens. I now have 12 there. 12 H pluses. Overall charge, or at least we've come across an ox. Overall charge of 0. Overall charge, wow, plus 12 minus 2 because there's 2 of the nitrate ions. Yeah, so that's plus 10. Add 10, E minus. And that's an ox. Oxidation is loss. Ox is out. Yeah, gain is in, ox is out. Next. By the way, I am expecting to make an error at some point. I mean, even I'm fallible. An iodate. Ooh. That there is going to iodine, I'm assuming? Okay. So this here, if you were to name these, this, of course, is iodine. Yeah, ene, because it's an element. Travels in a pair. This here is an iodate. Roman numeral 5. ion. That's an iodate 5 ion. And the reason for the 5 is because the iodine atom is in a +5 oxidation state. If anybody's confused by that, put it on the chat and I'll explain it. Otherwise, I will continue. Right. Moemi. Yeah. Metal, which is iodine in this case. 2 iodates for the iodines. Water, many. 6 H2Os there. Water. Acid, 12 H pluses there. Electrons. Overall charge on this side. Yeah. Overall charge on this side is 0. Overall charge on this side is +12 minus 2 +10 again. +10 E minus onto that side, and it is a gain. It's a red, not an ox. We had an ox there. We had a red here. Yeah, it's nice to see the iodate 5 ion. Very rare. I think we've actually got some in school, though. I think I've bought some recently. Yeah. I can't believe that nobody wanted me to explain that. Go figure. Next, mercury. Ooh, that's weird. I hope everyone spotted how weird that is. Mercury is in a pair. Hg2+ going to Hg pair 2+. That's very strange. Yeah, right. Balance for atoms. 2 mercuries. Balance for charge. +4 on that side. +2 on that side. Add 2 electrons. And we're done. Cool. Next. Ooh. I don't know if I just thought we didn't need to Moe. I just thought we didn't need to Moe. Well, you still have to balance the equation, Adam. You still have to run a process of some variety. If you don't want to Moe it, you can Moe this if you like. You're just going to tick off most things without having to do anything. You can always run Moe. You can have a singular exercise if you like. If I Moe'd this, yeah, if I Moe'd that, Adam, it's the same thing. Metal, mercury. Water for oxygen, don't need it. Acid for hydrogen, don't need it. Balance for charge. Yeah, it's the same process. Moe is great. Yes, Moe is amazing. Yeah, I need to teach that to all teachers because it's just one of the best things ever, Moe. That's why I wanted to teach you this now. You've misunderstood. Oh, okay. Have I misunderstood? Okay. You can't just go around kissing everybody, Adam. God, jeez. We've got vanadate. Ooh, vanadate 4. That is the ion there. This is vanadate 4+ IV ion going to vanadate 5. Isn't that clever? That's the vanadate 5. Yeah, vanadate 5 ion. Interesting. Right, Moemi. Yeah, metal. Vanadium, 1 and 1. Water for oxygen. 2 here, 1 here. Add water onto that side. Yeah. Next, hydrogens. Add 2 H pluses onto that side. Right, balance for charge. Right, on this side, +2. On this side, +3. Add 1 electron, and I'm done. Winner. This one, of course, ox is out, red is gain. Yeah, it's a reduction is the gain, and it has the word in it. There's it going in. Yeah. And then this is an ox because the electron's coming out. Nearly finished now, folks. S2. Oh, this is the thiosulfate ion. You've got to memorize this, by the way, guys, for A-level. Sorry about that. This is called the thiosulfate ion. Got to know that one for A-level. Going to S. Right. Metal, water, acid, electrons. Moe. Metal is sulfur. Need to balance for it. Water +3 H2Os. Acid +6 H pluses. Electrons. 0 on that side. It's the overall charge here. plus 6 minus 2 plus 4 plus 4 electrons, and I'm done. Sorry, I overran on the sheet. I'll move it over if I can. There we go. Move that over. Lost something. Uh-oh. Uh-oh. I've lost something. Did I? I don't know. I've gone and ruined that now. I've totally ruined it. What's going on? What's going on? H plus. 4 electrons. There we go. There we go. Moving stuff. Next, nitrate to the nitrite ion. Oh, old name, by the way, if anybody's interested. Very old name. So this is the nitrate ion. This is actually nitrate ion. Right, on the chat, give me the Roman numeral that goes in there, please. I want everybody to contribute. NO2 minus. This is the nitrate blank. I don't even, that's not, just ignore that ion habit. Right, guys, I just want this one first on the chat, please. What Roman numeral goes in there, please? Come on, year 12, come on. Come on, I'll weigh it while you're doing it. Metal, nitrogen, 1 and 1. Water, need an extra for oxygen. Hydrogens, 2 H pluses. Electrons, minus 1 on this side, plus 1 on that. I don't know that one. Plus 1 on that side, so add 2 electrons. Bring it down. Amazing. Done. Thank you. Nice that, Alistair. Everyone's giving me the same number. That's fantastic. Well done, year 12. Really proud of you. That's amazing. Just want to show you how that's done. I know that everyone's done it, which is great. I've got O2 minus times by 3 minus 6 in total. Need to get to minus 1. Nitrogen must be bringing a plus 5. Superb, year 12. Thank you. What Roman numeral now goes into this one? Go, go, go. Yeah, this is a fun game. Like it. Like it. Yeah. Let's get rid of all this junk. Do. Right. Yeah. There we go. Which one goes into there? Oliver is on it. Well done, Oliver. Oh, wait, DW. Look at that. Lovely threes appearing everywhere. Well done, everybody. Really proud of you. Really picking up this redox stuff. I'm really, really pleased. Yeah, well done. Nitrate 3 ion. Old names for those people who are interested. Nitrite and nitrate. Old names. Stupid old names. Lol. Anyway, just for those people who are nerdy like me. Okay, right, guys. Learning objectives. Let's add it up. Let's add it up. I'm going to add to my sheet for the next time of the red or the ox. Definitely. This one, reduction is gain. It goes in. Reduction is gain. It goes in. I like it. Okay, cool. So, marks 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's out of 14, folks. It's out of 14. Add on to the sheet, please. You guys know the sheet well. Yeah, go to the sheet. Yeah. Year 11 homework tracking sheet. It's out of 14, was it? Yeah, out of 14. Oh, thank you very much for putting that in for me. That's great. You can start inputting your data. It'd be lovely to see how you guys got on. Got half an hour left of my lesson. Let's see how you guys. Oliver 9. Oliver, you're better than that. Did you stuff up a couple at the beginning? Make sure you go over them right in the correct one, Oliver, to re-solidify it. Make sure you've done that. Well done, Alistair. 13 out of 14. Superb. Ange, outstanding. 12. Great job. Manisha, 12. Well done. Julian, well done. 13. No one's hit 14 yet. Come on. Come on, guys. Get your data in. Good job, Murdo. 11 out of 14 is really good. Really happy. Angel, how did you get on? Meryl's vanished again. Meryl, where are you? I don't know what I was doing at the beginning. It does happen. I'm so sorry. I disappoint. Oh, don't be silly, Oliver. Oliver, there's no such thing. Don't be silly. Thank you, Meryl. Smashing 14 out of the bag there. Well done. Oliver, I'm never disappointed with anyone. Anyone can make mistakes on redox equations. I do it all the time. Don't worry about it. Well done. Thanks, Meryl. Angel, 10. Well done. Great result. Aisha, data, please. Emmeline, data, please. Right. Let's crack on with our lesson today, folks. Right. So, combining equations, the mole calculating moles, and using Avogadro's number. There we go. Right. So we're starting the mole today, guys. I'm not going to have an awful lot of time with it. I need to do combining equations. I may alter the lesson title. But we just need to quickly talk about combining equations. So, new title. Combining equations. Now, you guys have probably picked up from me about I stuffed the 14 and 12. I don't know what that means, Ange. Will make sense to me. So you guys have seen me doing this combining equation process kind of in bits and pieces, but we haven't made any solid notes on it. So number one, so facts. No, rules, better. Yeah, better. Rules. When combining equations, when combining equations, A plus B plus C goes to D and E, E plus F plus 2 C's goes to G and B. When combining equations, number one, cancel substances, species, better word. Cancel species on opposite sides, cancel species. I'm going to color code this. This is green. Right, cancel species on opposite sides. Green, E and E. B and B. There we go. So you cancel people on opposite sides. And when I say opposite sides, everyone here knows I'm talking about on opposite sides of the equations. Yeah? Next, step number 2, combine species on same side. Let's do that one in blue. Let's do that one in blue. And we're done. Final equation, step 3, put together. The B's gone. A is still there. But there are 3 C's in total and an F. Yeah, I've just put everything left on each side together. Yeah, The A is still there. The F is still there, and I now have 3 C's. Yeah? Next, what's on this side? D is still there. 1 D and 1 G. And we're done. This is not complicated. So this is combining general equations. Does everyone follow? Not complicated. Yeah? Let's have a go at this, guys. I'm going to give you an example for you to do on the chat. Yeah? Okay. Take it away from you. Let's go 2 A's plus 3 C's goes to 4 B's and a D. And then I'm going to go 2 E's plus 2 D's goes to 4 C's and an A. Right. Guys, combine. On the chat, please. Go. Put those 2 equations together for me and spit out your answer on the chat. See how long it takes you guys to give me the answer on the chat. Who's going to be first in? Race to the finish line. Come on. It takes, but you know what? You can't rush, actually. I don't want you to rush, guys. Take your time. Get it right. It's better to get it right than to get it fast. It is so important, that. Yeah, I'm just playing games with you. That's all I'm doing. Cool. Oliver's the first person to answer. Let's check. Step 1, cancel what cancels. That's what I got. Does it match everyone else's? Yeah, I like it. A plus 2 E's. A plus 2 E's goes to 4 B's and a C. Well done, everyone. Great job. What about D? Oh no. Did I miss one? I missed one. I knew I was going to miss it. I missed out the D. You see, Oliver, even I am fallible. Yeah, it happens. That was it. I've got 1 A, 2 E's, a D, 4 B, yeah, and a C left over. Should always circle stuff. There's a good process here. It's easy to miss somebody. Yeah, thank you very much. Yeah, you guys got it right. I got it wrong. There you go. I missed the D. Very easily done. So, yeah. And there's me saying, take it slow. Get it correct. I'm an idiot. Cool. Well done, guys. Thanks, Ange, for letting me know. Good job. Spot on. Right. Okay. Combining half equations. New notes. When combining half equations, it is important to get rid of all electrons. An equation cannot, that's it, that's the only bit you really need. Combining half equations, get rid of all electrons. The question is, how do you do this? Multiply. Okay, let me show you. Let me show you this in action. So A plus 2 electrons goes to A2 minus. Is that oxidation or reduction, please? B. This is where I ought to give you real ones. No, I'm going to give you real ones. Going to give you real ones. Don't care. Going to give you real ones. Right. Going to give you real ones. Going to give you real ones. I'm running away in my head if you're wondering. Okay. So this one, reduction is gain. Gain is in, that's an ox. Yeah, we now need a reduction. That's an oxidation. We now need a reduction to go with it. Yeah, they'll always be on the opposite sides, the electrons, by the way, to cancel. Yeah, that's the important bit. Always be on opposite sides so you can cancel them out. Right, I need a reduction. Okay, metal is chlorine in this case. Add the waters, gonna need loads of waters on there. 6 plus, oh, that's interesting. Huh, totally didn't think that was gonna happen. I should have known it was going to do that. Plus, oh, that's awkward. Didn't want to do that. Oh, okay. Let's just do that then. Let's do that. That's what I want to do. It's better. Okay. Okay, folks. So this one is the example for me to show you this. We know that we're going to cancel everyone that cancels. Yeah? This is my red, and this is my ox. So we now need to combine these to give the overall equation. Yeah? So the first green light here, yeah, nota bene. If electrons on same side, probably an error. Yeah, error. Check it. If you've got two equations where the electrons are on the same side, you're probably wrong. It's the first point just to mention. Yeah, the electrons will always be on opposite sides. Now what we need to do is, if we combine these now, straight away, we're going to end up with 8 electrons because there's more on that side. We can't do that. What we're going to do is we're going to multiply. We want to make them have the same number of electrons. Step 1, multiply equations to make electrons number the same. So in this case, I'm going to times this equation here by 5. Right, times every, I'm going to put that in green, but in blue. No, blue, yeah, green, I don't know. I just want it to be nice and easy to read. Times 5. Right. 10. Oh, 20. 10. 5, 10. Right, electrons now cancel. Yeah, multiply equations to make electrons number the same. Yeah, step 2, cancel out. Step 3, combine, add together. So, cancel what cancels. All of those are gone, but I now have 8 of those remaining. Yeah, because the 12 of them cancel, 8 are left over. Water's all gone, 4 remaining. Anything else? Nope, that's it. Final equation. Final equation. Circle the people. Well, electrons are gone. I've got 8 H pluses plus 1 nitrogen plus 10 chlorates chlorate 1s, going to 2 nitrate ions, plus 5 chlorines, plus 4 waters. And I'm done. Let's now check it. Let's now check this, folks. Yeah? So, hydrogens, let's just do normal balancing. Hydrogens, 8, 8. Nitrogens, 2, 2. Chlorines, 10, 10. Oxygens, 10, 6, 4, 10. It balances for atoms. Does it now balance for charge? Yeah, I've got overall charge on this side is plus 8, 0, minus 10. Add it together, minus 2 in total. On this side, minus 2, 0, and 0. We're good. Equation's correct. Isn't that amazing? Balancing, combining half equations. We're done. That's it. Did everyone follow? One other go. All right, you ready? Let's go for, I'm trying to think of real life reactions now, which would actually be useful. Oh, can. So, oxidation of alcohols via potassium dichromate. Cr2O72 minus, going to Cr3 plus. Next, balance the half equation, folks. Ethanol is being oxidized to ethanoic acid. Did this at GCSE. Balance the two half equations. So let's weigh them. Metal, carbon in this case, 2 and 2, that's okay. Let's just do one at a time, shall we? Metal, water, acid, electrons, plus 12, plus 6, add 6E minus. Right, next. This is now ethanol to ethanoic. Carbons, done. Water, 1, 2. Acid. Need to check that H's. Need to check that one. That one's going to be a tricky one, isn't it? Got to count all of them. Metal, done. Water, done. Acid. Right, I've got 2 H's plus 6. So 8 hydrogens in total. On this side, 4, 5. So 4 in ethanoic. I need 4 there to get it to 8. So that makes 8 hydrogens. Amazing. Next, add electrons. Add 4 E minus. Right, done. Okay, guys, we need to multiply them so that the electrons disappear. The first common denominator between 6 and 4 is 12. So I'm going to times this equation by 2 and this equation by 3. If I do that, the electrons will be 12 on each side. Let's do it bit by bit. So 12, 28, 2, 4, and 8. There's times by 2, done. Next, times by 3. 3, 3, 3, 12, and 12. Cool. Looks like 14. 12. Amazing. Right. Okay, cancel what cancels? 28 minus 12, 16. Waters, 3, 5. We're done. Final equation. 16 H pluses. 16 H pluses, though all those waters are gone. 2 dichromate ions. 3 ethanols. Going to 4 chromium 3 pluses plus 5 waters and 3 ethanoic acids. We can check it. Let's check it. So let's just do atoms first. Hydrogens a lot. 16 plus 6, 22. Yeah, I've got 12 plus 10, 22. 4 chromiums, Oxygens, it's going to be a mess. 14 plus 3, 17. 5 plus, that there is 4, have I miscounted? I miscounted, didn't I? I miscounted. Oh no, this is the problem you see when you get to this point. Guys, I've miscounted. I'm pretty sure I've miscounted. There was, oh no, hang on, no, 7, it was 7. Why was it 8? Why did I get to 8? I don't know how I got to 8. There was, how did I get to 8 instead of, oh no, made an error. This is the problem, is if you do redox and you fumble a half equation, there you go. Oliver, totally reasonable. Yeah, we all do it. I've just got to start again, because otherwise trying to track down that error is a nightmare. It really is. There's not really much else I can do. Let's go back to the original equations. These were my doubled numbers. I made an error. Chromium's 2, 7. Yeah, and then 14 plus 6. That's correct. What did I do to that 7? Did I take it to an 8? I did something funny, didn't I? That equation was that. It's so easy to fumble it. Yeah, this is why it's hard. Even start the question again. I have no choice. Ange, I really do. That is all I can do. Yeah, so carbons, water, did that. Hydrogens, we had 8 on this, 6 hydrogens here plus 2, 8. So I needed to put 4 there. Yeah, and then 4 electrons. There's my original equation. I still get to the 12 times by 2 times by 3. I made a mistake somewhere, just with a number. Yeah, 12, 28, 2, 4, 14 waters. That was my mistake. Found it. Right, times by 3, 3, 3, 3, 12, and 12. Cancel what cancels? Electrons, all gone, 12 and 12. Right, I'm going to build this piece by piece. I'm just going to do it in a highlighter as well. So those entire 12 vanish. 12 of H pluses disappear, and I had 28. That's going to be 16. 16 H pluses. Okay, done. Yeah, next, waters. 3 cancel. Yeah, 3 cancel. And I get down to 11. There it is. That's better. It's going to work out now, isn't it? Yeah, I don't like doing it in all these colors. What else? I think that's it. Yeah. So add it all together. 16 H pluses plus 2 dichromates. See, you can always check this and realize that you've made an error somewhere. Yeah, there's ethanol. I'm going to have to do this again, and I'd be hilarious if I got it wrong again. It'd be brilliant. 4 Cr3 pluses plus 3 of those ethanoic acids and 11 waters. That was the trick. There was the mistake. Right? Realize I'm not going to do any moles today. Oh dear. Brings us to the end of the lesson. Check it. 16 plus a lot. 16 plus 12. 16 plus 12. 28. 28 H's. 28 H's. 11 times 2. 22 there. Plus 6. 28 there. 28 hydrogens on both sides. That's okay. Tick. Chromium's 4 and 4. That's okay. Chromium's 4 and 4. Oxygens. Ugh. 14. 14 plus 3. 17. 17 oxygens on this side. 3 plus 11. No, it's not 3, is it? It's 3 times 2. 6. 6 plus 11, 17. 17 oxygens. Charge. So all the atoms add up. What does the charge do? Yeah. So let's just check the charge. On this side of the equation, I've got 16 pluses, 2 minuses, so minus 4, and 0. Total plus 12. Yeah, next. Plus 12, 0 and 0. It all adds up. We're done. Right, guys. I'm going to set you a homework of combining half equations. It's going to be good practice for you. We're done combining equations for today. I'll put that onto my, I'll change my YouTube channel 1. Emmeline still has not inputted her number. Right, guys, sorry it went on. I didn't think I was going to spend that long doing balancing and combining equations. But of course, what ends up happening is you're doing the process of balancing the half equations all the time. And so it's not really much you can do about it. Sorry that it took longer than I thought. I will leave you guys be. I'll change the title of this and get rid of the moles and just do combining half equations. I'll set you guys the homework for Wednesday. I'll see you all on Wednesday. Have a great rest of your day, folks. See you later, guys.